Great. Well, welcome everybody to this webinar on, we're going to be speaking about a new computer software testing tool that we've been developing, and I'm just watching the participant count increase as I speak to you. So we'll just give folks a couple more minutes to join us and say a few words. So please just bear with us. Maybe we'll wait a couple of minutes. Thank you. And for the folks who are joining, we're just waiting a couple of minutes for the registered participants to join. So we'll just start at 2 or 3 minutes past the hour, past the half hour. Thanks. Okay, I'm going to go ahead and get started. Hello, everyone, and welcome to this webinar. We are going to be speaking today about a new software tool for testing the energy efficiency and the performance of personal computers operating in the active mode or the on mode. And these are products that are covered in Lot 3 of the Ecodesign regulation. My name is Michael Scholand. I work at CLASP Europe, and with me today are Paolo Tessarati from the European Commission, who will say a few words after me, and then the team at GTD GmbH in Germany. That's Andoni, Yuan, and Thomas, and they will be taking you through the detail and the technical discussion on the software tool. So just before we jump in, for those of you who don't know us, CLASP is a nonprofit, non-governmental organization that specializes in and focuses on the improvement of energy and environmental performance of the appliances and equipment that we use every day. So here in Europe, that means we primarily work on the eco-design and energy labeling directives and supporting products, and many of you know us from the consultation forum where we are stakeholders and provide input there. My name, as I said, is Michael Scholand. I've been with CLASP's Europe team since 2010. So this is our agenda for today. We are starting out with just the introduction. Paolo Tessarati, as I say, will talk about the motivation behind this software tool that we've been developing and the task that is at hand. And then we'll hand over to GTD in Germany, and they will walk us through the tool, giving us an overview of the tool, the architecture, the setup for conducting testing on units, on computers, the procedure to follow when conducting those tests, and then the worklets themselves. So you can see what is embodied in this on-mode active testing of the computers. We'll then have half an hour at the end for questions, answers, and discussion. And then we just say thank you, and you can go home. So that's our 2-hour plan for today. Just a few housekeeping points. Please keep your microphone muted so it's clear for hearing the speakers. Don't run your video. Some people may have some bandwidth problems. We'll just have the video running for the people speaking. If you don't mind editing your name in the chat group so that it includes your organization, that would be very helpful for when you post questions. So comments and questions, we ask them to be put in the chat box as opposed to the Q&A box. It's a little bit easier to handle and it's more visible to both those of us on the sort of webinar administration side as well as the audience. If you put it in the chat box, everybody can see the questions, everyone knows what's being asked, and then we will answer those in the Q&A session, or in fact, GTD may invite questions in the course of their presentations. It's just over an hour, so people will be able to chime in and we'll have little Q&A sessions there. This presentation is being recorded, as you should have been notified when you logged in today, and we are going to share a copy of the slides, both these intro slides as well as GTD slides, with everybody, and there will also be a link and password for the actual presentation if there's anybody who missed it, who wanted to attend. So just one slide on what we're speaking about today. This is a software tool to measure the energy consumption and the performance of personal computers in active mode. So CLASP and GTD have been working together on this activity for just over 2.5 years now. The tool is designed to accurately assess energy use and performance of a computer executing tasks, to be agnostic of the operating system, the architecture and configuration. So it should operate in Windows, Mac OS X, Linux, Google Chromebook, like all the operating systems out there, we should be able to test equally. It should be low cost and easy to use. So manufacturers are able to conduct testing to label computers for sale, but also market surveillance authorities will be able to conduct testing to verify compliance with the regulations. And finally, be based on open source worklets and software, so it can be independently reviewed and updated and maintained over time. So those were our guiding principles that we followed for the last 2.5 years developing this tool. CLASP and GTD would like to thank Digital Europe and their members. They have been a fantastic critical friend and supporting team, reviewing the drafts, reviewing the worklets, testing and giving us feedback on what's working, what's not working, what needs to be updated. That's been going on for over 2 years now, and we're very grateful to Digital Europe and their members for that, so thank you. And we also want to acknowledge Unity Software and Underwriters Laboratory. They both provided some high quality content in the 3D graphics, which is utilized now in the current version of the tool. This makes sure that the testing of graphics renditions are current with current software. So we're very grateful for them sharing that content for this purpose. And then finally, I just had a request for data. So if you click on that link when you get the slides on the CLASP website, you can find the software tool itself, a little write-up about it, and the manual for how to do the setup that you see here on the right-hand side, and the procedure that you follow for conducting the test. We would like to invite participants and stakeholders on the call today to conduct testing of computers in their laboratories and to share those test results with the Commission, with the GTD and ourselves and Digital Europe, as we're, well, for the Commission to conduct the impact assessment, and also for those of us using the software tool to check that it's working and to make recommendations for label classes and performance levels and so on. So please do give it a go. I know at least one market surveillance authority has used it and successfully in the past, and we would invite many more to try it out and share their data. And now I want to hand over to Paolo Tasserati. Paolo, are you there? Yeah. Would you like to say a few words to set the scene? Thank you.
Okay, thank you, Mike. I was invited to provide some information just for setting the scene for those of you today here that were not involved in the previous phases of this work. So please, next slide. So basically, just to collocate, to set this work that is ongoing. As you certainly know, the current computer eco-design regulation had to be reviewed a long time ago. We had a preparatory study on that, and the study confirmed that the regulation as is now is rather complex for everybody, for suppliers to be understood, for market surveillance authorities to perform the checks because of a extremely complex setting of the requirements in the legislation that match basically the specifications 5.0 of Energy Star. So the study also confirmed that the assessing the energy efficiency while in idle, as is done in this regulation, is not relevant anymore, and this is basically because of a incredible progress that was driven mostly by industry with the aim of optimizing the energy consumption of processor and all components in a computer, mostly to prolong the battery lifetime. So this progress is mainly driven by portable computers. However, the preparatory study did not find any workable solution for assessing the energy efficiency of computers when not in idle. Some research was done, but no tool available in those days was fit for our purpose. So because of a workload and our political facts that were happening in those days, basically our priority on the review of the eco-design for computers was lowered, and the work temporarily frozen. Next slide. But finally, we had an exchange with a CLASP. Here there is a mistake. It was not January 2019, but a year later, probably. We had the first meeting here in the commission premises where we invited engineers of a major manufacturers invited via DIGITALEUROPE. And we had a first discussion that triggered all this work for the Worklets that now GTD will present. Okay, all the GTD with CLASP and with DIGITALEUROPE members have worked a lot so far. A lot of tests have been done with a collection of suggestions for improvements by GTD, requests of changes, provision of testing data, and well, basically the result is more or less that from 46 worklets that were presented at the very beginning of this project, not the very beginning, but at a certain moment, then we are now to around 2022 that are the most relevant and interesting and apparently fit for our purposes. Next slide. And then my last slide, as I'm always asked about the timeline. Well, finally, after a procedural accident we had, we are now going to launch the update of a study with an impact assessment. So we can foresee that this spring we could have a consultation forum where we would discuss the first findings of a study, and we could discuss also an early draft of a regulations. I say regulations because currently we have only eco design, but the idea is to propose a labeling measure as well to better inform users for informed consumer choice, but also possibly to facilitate tendering for imagine all public administrations, universities going to tender hundreds of computers at once. And okay, if everything runs smoothly during the summer, we will work for all the procedural steps, including the drafting of a transitional methods and preparing a standardization mandate, not only on this tool that will be presented today, but also possibly on non-energy tests to be done that we have already in mind. And then, of course, there is the approval by the Impact Assessment Board and all the consultations as usual. And normally the regulation could have an application from end of 2024, hardly before. That's all from my side.
Super. Well, I'm gonna stop sharing now and pass over to GTD. Muted at the moment, Andoni, just so you're aware.
Yeah. Okay. My name is Andoni Arrey, and I'm going to introduce in a bit the work that we have been carrying out during the last years in developing this tool. I'm the general manager and also the project manager for the tool that we have been developing, and I will guide you through the first slides and the introduction we will make about the tool. After that, I will hand over to my colleague Thomas Bucha. He's going to explain more exactly how the procedure of testing goes, and we'll perform a live demo. And towards the end, we'll then go briefly through the different worklets that we have within the tool right now, as it is configured after this 2.5 years of work. First, very briefly, then next slide, please, Thomas. Yeah, as I said, these are the 3 pieces. Let's jump over that. Just a brief word about GTD itself, since many of you won't know our company before. We're a software company here in the south of Germany, and we're part of a bit bigger group than the company in Germany itself. It's the GTD group, which is mainly a Spanish company. I mean, we have the headquarters in Barcelona. It was founded in 1987, and nowadays we have a couple of sister companies throughout Europe. So right now it's mostly a European group acting in several industries. What we usually work for is really where we get, let's say, most of the projects is from the European space industry. That's our main work. And apart from that, we also work for different German federal institutions like the Umweltbundesamt or the Bundesanstalt für Materialforschung, which also does the tasks of market surveillance in Germany here. And we also have some members present now among the attendants. That's all about GT itself. So let's go for the tool then. The tool that we have been developing has a couple of main ideas that are behind the whole work that we have been carrying out. What we did is a work based on an open source piece of software, which is called the Phoronix test suite. So this is an already existing test suite for usually at least computer performance. And what it does is it runs a series of worklets. And what we understand as a worklet is a certain configuration or setup of a piece of software which carries out a series of tasks as it has been configured to do a certain concrete work. And what the complete test suite does is then to run through these worklets and run all the work that has been configured step by step there. Just to give you a grasp of what we're talking about, one worklet could be a computer program used for creating spreadsheets, for example. That could be one piece of software we take as a basis for a worklet, and then we configure it to run a couple of work steps within that worklet on that piece of software. One main feature that the tool we developed has is that all the executables we run are native binaries on the different operating systems that we support. And the different operating systems that we support are Microsoft Windows, Mac OS, Linux, and also Chrome OS. So roughly, mostly all the operating systems that a European consumer can get when buying a certain computer. And again, we use no virtualization in between. All the executables we run are native binaries for that platform. On the other side, the power measurements we do, this is also an important aspect, do not alter the performance nor the power demand of the task that is being carried out while being measured on the unit under test. And in the end of the day, what the tool does is to merge all the results we got on the performance side and on the energy consumption side to get an overall measure, a single meta efficiency in the end of the day for that system being measured. Next slide, please. A couple of words about the underlying test suite architecture, let's say. The Phoronix test suite, it's a cross-platform tool. So it runs on Microsoft Windows, it runs on Linux, it runs on Mac OS. Since it's written in a scripting language, it's written in PHP. So this guarantees that we can run it on all these operating systems. It already automates the whole testing process that we need to carry out from the very beginning, where we need to install all the dependencies and all the software pieces that we need to execute, to the complete results aggregation that we need in the end of the day. It already has a huge set of pre-configured worklets where we got the first drafts, let's say, for the configuration that we have been proposing right now. So we had an easy starting point, let's say. It is already also very extensible for our own use case. Let's say we were really able to do all the changes that we needed to this tool so that it could fit our specific purpose here. And it also already, let's say, comes or provides a couple of ways to present the results in the end of the day. So it does have a result viewer as a web application, and on the other side, it also provides options to export the numerical results of the measurements to a different format, like a CSV, so that it can be afterwards also processed. It also supports a couple of different measurement devices on the power measurement side, and this was also something that could be also then extended afterwards by us, so that it supported those devices that were required by industry up to now. And another nice feature is too that we don't need any external connection to the unit under test to be able to run the test. This means that we can leave the unit under test really without unneeded connections, which would alter again either the performance or the power consumption. Next slide. Even if the Foreign test suite already brings quite some features that are very interesting for our use, of course, we still needed to do quite some changes, and this has been in part the work that we have been carrying out during the last 1.5 years. So just a couple of points to address here are that we needed to do a specific merging of the power data measurements that have been carried out together with the performance measures done by the tool itself. This is a new feature which was not coming off the shelf with the test suite. We also needed to implement and support the ways how the efficiency was computed, because it was not off the shelf as we, together with DIGITALEUROPE and CLASP, decided was the best way to compute this efficiency metrics in the end. We had to do a couple of changes to make it better work under Microsoft Windows, to extend the exporting features that the tool had, and of course a couple of other optimizations and bug fixes that were necessary to make the tool reliable enough for our purpose. A couple of definitions to make you aware of what you are going to see afterwards when we run the live demo. For each of the worklets, what we have here is that within the configuration we have on one side the definition itself of what the worklet is. We also have a definition of what kind of results we're going to get from this worklet. We need also to define what the worklet really needs, so what needs to be installed on the unit under test so that we can run the worklet. And then we have the scripts that on one side install the worklet itself on the computer, and on the other side run the worklet as we have it configured. So this is what comprehends, let's say, on one side the concept of a worklet. As I said before, a worklet can be based on a software tool like, for example, a spreadsheet program. And then on top of this, we say then, okay, this spreadsheet program will need to be downloaded, installed, and then these steps of work we're going to carry out throughout the worklet, and then gather the performance results of this work. Next slide, please. The test suite as the integrating component, what it does in the end is it defines the series of worklets that need to be run for the last goal of getting the complete performance and energy consumption metrics. So the test suite is the aggregate, let's say, of all the worklets run in series and all the general configurations of the worklets, how they should be run. This is a short overview. We'll go into detail afterwards, but just to let you know then how overall the overall setup of the test configuration is. The most important components right now, just that you get a feeling of it, are the unit on the test in the lower left side, the controller computer, which we need to get the power consumptions on the lower right side, and then you also see the power meter and regulated power supply, which are the main components. This is just an introduction to give you now an overview of which pieces of software we need to install on the different components that we are seeing here. Next slide. The power measurements themselves are done using the data that we get from a power meter, like for example, a Yokogawa device, a Hioki device, and this we're doing using a software tool called Sqlite, which is open source and gives us all the features in the end of the day that we need to do our own work on our side, but gives us the necessary features to be able to talk to the power meters that we integrate within our tool. So Sqlite does run on all the platforms that we support, so Microsoft Windows, macOS, and Linux. And it is independent enough so that we ensure that we can support in the end of the day all the power measurement devices that we intend to support. Right now, what we are supporting are these devices of Yokogawa and these devices from Hioki. Others can be added, but this really depends on the need of the laboratories that the manufacturers have. We also use a different means of getting data from power meters that are connected via GPIB, but this is just a detail aspect, let's say, to let you know that we can support quite a broad arch of different power meters. Next slide then. As you have seen before, we have on one side the so-called controller computer, which gets all the energy consumption measurements and provides those to do the merging during the day between the energy consumption measurements and the performance measurements. So on the controller side, what we need is PHP as a scripting language to be able to support the Foronix test suite. We need the drivers, the USB drivers, to be able to read from the power meters, and we need a time server to ensure that we have a proper time synchronization between the controller PC and the unit under test to ensure that all the energy consumption measurements or power measurements fit to the power to the performance measurements that we are getting on the unit under test. And then we need, of course, a certain configuration of the Foronix test suite itself. Next slide, please. Then on the equipment on the test or unit under test, what we have is, again, we need PHP support to be able to run the Foronix test suite. We need an NTP client to get the time synchronization from the controller PC. We need all those third-party software components that make the core of the worklets that we're going to run. Just to give you a couple of examples, LibreOffice, FreeCAD, Blender, all of them are free software components that we use as the core for the definition of the worklets. We need Sigwing also as a support for running all the scripts that are part of the tool on Microsoft Windows computers. We need a certain Foronix test suite configuration, the test suite itself, and all the worklets according to the specific definition that we have in the XML. We have a graphical user interface, which is a quite simple one, just to give let's say a direct view of the underlying features that the test suite itself has in the end of the day. It is just I mean, you will see it afterwards in the live demo, but just to give you a feeling, it is quite simple graphical user interface. Next slide. And below this, what we have is a command line interface that in the end provides all the functionality that we need really for the execution of the complete test suite. And this is what is, let's say, hidden usually by the graphical user interface. But the command line interface itself, also for an intermediate assessment that could be interesting for you right now, the command line interface gives quite a good, let's say, way to handle all the features that a complete software tool gives right now to the end users. And that's really it from my side. I'm going to hand over now to Thomas. Thomas will make a short presentation of the setup itself and then go through the live demo.
Thank you, Andoni. I'll just move my microphone over so you can hopefully hear me well and also see me. Okay. So we have again the image you already saw with the test setup, but I tend to go into a bit more detail right here. So you already know we have a controller computer and a unit under test or equipment under test. Of course, we need to measure the power used by the equipment under test. So we need a power meter and a measurement adapter where we connect the unit under test. It's also recommended, at least when you do professional tests, that you have a regulated power supply so that you actually know that you have clean power without any disturbance within and that your power measurement is actually clean. Furthermore, there is a USB key which is used to transfer the power measurement data between the equipment under test and the controller computer. Yeah, you will see that in a minute within the live demo. The reason for that is that we wanted to have the minimal amount of communication between the unit under test and the controller computer to not impact either performance or the power measurement in any negative way. So data is transferred manually with the USB key. I think there will also be another image exactly. This is kind of the timeline which happens when you run a test. So starting on the left side, you will start the recording of the power measurements as the first item. Then you start the worklets on the unit under test. Once the worklets have ended on the unit under test, you end the recording of the power measurement data. Then you transfer the power data via the USB stick to the unit under test. It will do the merge between the performance and power measurements to create the final results. And yeah, then you get a folder with all the results, and you can move that back to the controller computer for further assessment. Currently, the test runs, yeah, depending on your computer, within an hour, or if you have a very slow computer, it might take a bit longer, like 2 or 3 hours. But this is quite an improvement compared to the initial version with the 46 worklets we had in the beginning. As Paolo already mentioned, that one took around 7 or 8 hours, even on the fast computer. So it's quite an improvement. And also the power and performance merge usually takes less than a minute. So this is quite fast. Okay, we are now coming to the live demonstration. So what I will show you is how to install the software on the equipment under test and on the controller computer. Then we will start up the software. We will synchronize the time between both computers. That is, of course, important because you want to exactly match the power data to each of the worklets. We will run a few worklets. I guess it will only be one because we don't want to wait too long. We will merge the power data with the performance data, and we will take a look at the result viewer. And yeah, we can uninstall the software in the end if we want to. Here's a picture of my demo setup. So what we have today is actually the real power meter we usually use here at GTD to do our tests. But of course, we don't have a controller computer and a equipment under test because it would be too cumbersome to share screen from multiple machines and switch between them. So basically, we have only one computer running 2 virtual machines, one for the equipment under test and one for the controller computer. And we can see both at the same time and do the demo within there. Of course, this is not a representative power measurement within a virtual machine. That's not what you usually want, but for the purpose of the live demo, this works quite well. There's also another image from the backside, so you can see the power meter and the measurement adapter. And the laptop is plugged into the measurement adapter, so the power meter actually sees the power data from the laptop. Okay. I will then switch to the live demo. So we have the 2 virtual computers here. You can see on the left side the equipment under test computer, and on the right side the controller computer. I have it as a text on the wallpaper, so you can see exactly what is where. There are, of course, a few steps which I cannot show you due to time constraints, but there is, of course, a very detailed test procedure document which outlines every step you have to go through for setting up your computer. Yeah, this is like steps like setting the wallpaper, disabling firewalls, whatever is necessary. So I will only go through the main setup of the software, and yeah, I will start by connecting the USB disk or the USB key with the software to the equipment under test computer. Yeah, it will just pop up Windows Explorer. You can run the Windows UUT install binary. From there is, of course, also one for Linux and one for Mac OS. So depending on whatever operating system you use, you choose the appropriate one. And basically, you just click Install Test Prerequisites, and it will do whatever is necessary to install all the software. It is actually already installed on this virtual machine, so it should be quite fast, hopefully, because otherwise, yeah, it would take a couple minutes, and I don't want to make you wade through all this progress, you can also click here on the Show Details Information button. Then you get this extended window where it will tell you what it's doing, copying files, installing programs, whatever. But you can also see the status here. It tells you it's dependency 8 of 8, so it's almost finished. So we can see it's now starting up the Phoronix test suite to make sure that all the worklets are actually in place. It takes a bit on Windows. On Linux, it's a bit faster for the startup, but hopefully it will finish in a minute. So we can see it's checking all the external dependencies. It's listing all the worklets it's going to install. And it's telling us, all the files have been processed successfully. And now it's done. You get a pop-up box saying that everything was fine. And that's basically the main process for the equipment under test. With that done, you can disconnect the USB stick from the equipment under test. And what it did install on the equipment under test is actually this folder here on the desktop that will be created by the installation. When you open that up, you have everything to run the test. So the USB key is not connected to the equipment under test while the test is running, because that would again impact performance quite negatively, or power measurements. You do basically the same on the other side, on the controller computer. So I'm connecting the USB key here. There's also an executable for the controller side of the software. Can just start that up as well. And it's more or less the same as the first step. You click Install Prerequisites. It will pop up this utility for installing the USB driver. I already did that for our power meter, so there's nothing to do here, and I can just close that out. There is, of course, a detailed explanation in the test procedure on what has to be done here. And again, you can pop up the detailed information to take a look at what it's doing. So it's also installing Phoronix test suite, because you might want to use the result viewer later on, and also, of course, the configuration for everything. So it will also just take a minute. And that's it. As the next step, you can already start the NTP time server with the Start Time Server button. That is quite easy. And you can also check the connection to the power meter. I have to make sure that it's actually connected. So, and then let's see if the power meter is detected. And yeah, it looks good. It says it found a device, the Yokogawa WT310E with a number of measurement channels, which is exactly as expected. Okay, now that the controller computer is prepared, we can also start up the software which was installed on the equipment under test. And there we get a few input fields. So you can give it a name of the test configuration. This could be, for example, the name of your new computer you want to test or whatever. And the description, I will just put test because that's good enough. Then you have to type in the IP address of the controller computer so that it can synchronize the time. This IP address is also visible here in the controller computer user interface. So I will just type that in. And then we can just click synchronize clock. Obviously, the clock is more or less in sync, I would guess. Yeah, it is. Usually the virtual machines, they synchronize just to the clock of the host computer. But anyways, we can click that button and wait for it to do its thing. You will also get a few debug messages, or if there is an error, of course, you will also get an error message in the graphical user interface, and you can see then what happened in the detailed status. For the moment, everything looks to be fine. It tells us the clock has been synchronized with a quite nice accuracy. So everything was successful, and we can start the actual test. So basically, where we are right now is at the very beginning of this diagram I showed you on the last slide. So now we can start actually acquiring power measurements with the button on the controller here. And it will just say status is working. So it's accumulating power measurements, however long it is necessary. And on the equipment under test, you would now just click the run test button. I'm not going to do that because this will obviously run all the 22 worklets, which takes a bit too long, and I don't want to make you wait for a couple hours. So you can go here into the configure worklets window, where you can actually choose which worklets you want to run. And I will now run only the LibreOffice Calc worklet because I think it's one of the nicest ones for a demonstration, because you can actually see the worklet working. Most of the other worklets, they run in the background, so they don't have any visible windows, which is a bit boring. But for the LibreOffice worklets, you can actually see them doing something. And then there is another setting which is important, which is called number of worklet repetitions right here. Usually the software tries to repeat the worklet as often as necessary for statistical reasons. So if the software detects that the performance results are not consistent, it reruns the software as often as necessary. But obviously we don't want that because it increases the time of the demonstration. So I will just set that to 1 to make sure it only runs the worklet once. You can also configure a pause in seconds between worklets. That is more or less just a feature for testing how that affects performance or power measurements. This is usually interesting on laptops where you have tight thermal constraints. There this might make a difference. Of course, in the final version of the tool, such a setting wouldn't be included. So it's currently more for evaluation of the tool and evaluation of the worklets. There is an interesting checkbox here for running the worklets in debug mode. We don't need it today, but if you should do your own tests and you encounter a problem with any of the worklets, it might be useful to run it in debug mode, because then you can actually see a lot more information about what the worklet is doing in the background. And this is then also helpful if you report an issue to us. Then it would be great to run it in debug mode. Okay, so I'll just accept that, and then I will do run test, and we can see all the stuff happening on the right side. And as soon as Phoronix Test Suite has started up, which takes a couple of seconds, we will also see that LibreOffice is then starting up with actually doing the work which we want to measure. So Phoronix Test Suite usually collects a bunch of meta information about your computer. This is what it is currently doing right now. This is stuff like your screen resolution, the amount of memory installed, what hard drives you have, the name of your main board, what operating system version. You can also see part of it printed out right here. This is then quite useful when analyze your results, the computer you tested, without having to type in all the information manually. So we can now see LibreOffice is launching, and it's loading up the spreadsheet for the test. For this test, it's a Monte Carlo simulation, and it does actually change various parameters to rerun the simulation several times just to simulate whatever a user might be doing within such a spreadsheet. It's quite nice that you can actually see the worklet. As I already pointed out, most of the worklets are running in the background and you can't see anything. So that's quite nice. Okay, once all the worklets are run through, obviously we only ran one here, so it was quite quick. You will get a message notifying you to insert the USB drive for the power measurements. So for that to happen, we have to stop acquiring power measurements on the controller computer. We will just say measurement complete. We can close out the software and remove the USB key. And then attach the USB key to the other computer. And once that was recognized, yeah, we can click yes to continue the process, and we get a success message saying the task was finished successfully. And that's basically it. Test is done. So we can also close this software. The test results are located in a folder test results here on your desktop in the energy efficiency testing folder. So usually you want to copy that just to the USB key. And then we can eject the USB key. Still in use. And that's basically it for the equipment under test. So I'm just going to close that. We don't need it anymore. And usually you want to analyze your results then on the controller computer, because then you would have your library of all your tests. So you can start the controller application again. And then just click the Open Result Viewer button. This will open up the browser. Okay, yeah, I never used Edge on that computer, so it's trying to force me to make a Microsoft account. That's nice. Okay, now we are here in the result viewer, and what you can see right at the top is the test that we've just ran. So we can click into that. And we can see at the beginning all our metadata about the computer we've tested, type of processor, type of the motherboard, amount of memory, hard disk, operating system version, and so on. Then we get a table with all the performance results. Obviously, we only have one worklet, so we only get one result. And then we get various graphs with all the test results. So we get the performance result, we get a efficiency result, and we can also see the system power demand, which is basically the raw data from the power meter. Obviously, it's not very interesting to have a test result which has only one worklet run. So I will switch over to a more interesting result. Let's take that one. And here you can see how it looks when you actually run all of the worklets which are included in our test suite. So you again get the table with the metadata, you get the table with the performance results of all the worklets, and then you get a graph for each of the worklet. So again, performance result, efficiency result, and the system power demand from the power meter. You can also see that the worklet was executed multiple times. So you have 3 power measurement curves here. So it's quite nice to compare if the power measurement was actually repeatable or reliable. And you also see it in the result. You get here an n equals 3, saying that you have run it 3 times, and a standard error, which is then calculated from those 3 results. So you just get a bit more reliable results. obviously, we need to fuse all these results into a single metric to then be shown on a potential energy label. Currently, we are fusing them with a geometric mean in a so-called meta efficiency, which is then shown right at the bottom. This is, of course, not the final formula yet, so this is to be decided. There are different possibilities on the table, but currently we have this geometric mean as the meta performance. One more interesting thing you can do with the result viewer is that you can actually compare systems. So you can click this checkbox right next to each of the test results and then click compare results. And it should open all those results. And of course, you get then the same tables more or less with then all of the information from the systems. So you get all the metadata about the computers. You get some nice graphs showing you the different performance results in this case, and also a graph for the per watt results. So that's the efficiency. And yeah, that's quite nice to get an overview across those compared systems. Of course, you get the same table as before with multiple columns showing all the performance results. The red result is the worst one, and the green column is the best result for those compared computers. And you also get all the details regarding each of the results. So the performance results, the efficiency results, system power demand for all of them, and also the result confidence. And of course, the same happens for the meta efficiency. So you can see here, the computers are quite different in meta efficiency. So there is an Apple laptop which has a meta efficiency of 14, and I'm not sure if those are desktop computers. They are quite low in efficiency compared to the Apple laptop. And you also get the system power demand monitor. So that is essentially the raw data from the power meter without being split up into the separate worklets. So you can see how the system behaved during the whole run without going through each of the worklets separately. Okay. Once you are done with all the testing, you can uninstall the software. It's the same for the equipment under test and for the controller computers. So I'm showing it only once. So basically, you open the application from the USB key, as I already have it here, and you click uninstall prerequisites. And it takes a couple seconds. The equipment under test takes a bit longer because there's much more to uninstall. And you will get the message, everything is gone. And essentially, your computer is as good as new. Okay, so far for the live demonstration. I will then come back to my slides and will give you a quick overview about all the worklets we actually have. So there are different categories. I categorized the worklets within those slides, roughly grouping similar ones. So we have in the category artificial intelligence, a worklet based on the Stockfish chess engine. So it uses neural networks to play various chess games. And you get a result in nodes per second. I think Stockfish is relatively well known in the computer chess space. And I think it's a great software. It's obviously open source, as most of our worklets. I will mention the non-open source ones explicitly. Great artificial intelligence workload. Then we have, as the next category, various image, audio, and video workloads. So there is TJBench, which is part of libjpeg. So yeah, if you would create software which reads or writes JPEG images, you would probably use libjpeg. So it is quite heavily used in the open source space, and it comes with its own TJBench called Benchmark. So that will do encoding and decoding of JPEG images, and basically measuring how many megapixels of image data your computer can encode or decode. Then we have a worklet for Mp3 encoding. Mp3, I guess everyone knows, is the famous audio format. So it will use the lame encoder, also open source, and encode a example and WAV file to the Mp3 format, and it measures the time needed for doing this encoding. For the video workload, we have Handbrake. That is using hardware acceleration if possible. So if you have an NVIDIA or AMD or Intel QuickSync capable computer, it will use that acceleration hardware to transcode a H.264 encoded video to H.265. That are the two different video codecs which are in play here. Also, the result is measured in seconds for the encoding. One special thing about the Handbrake worklet is that it includes a quality check, because we wanted to make sure that the hardware accelerators actually produce more or less video of the same quality. So it includes a quality check based on FFmpeg to make sure that no one is cheating by decreasing the output quality of the hardware accelerator. For database workloads, we have a workload based on Sqlite. So Sqlite is an SQL database, which is quite useful to be used in applications. So it's not a full-blown database server as you would know from your local computing facility or whatever, but it's usually used in the background of many applications, be it your email client or your web browser, to just store the data. The worklet itself creates a database and inserts various data into this database. It can be configured to run with different amounts of threads. Currently, we only have the one-thread version because we think that this is the most relevant use case for end users, compared to other workloads which are more relevant to server space. Again, we have the results measured in seconds for running a defined set of SQL queries. We have one benchmark coming from the programming language sector. This is PyBench, so it's a benchmark written in the Python language, and it measures the performance of the Python interpreter. Python is quite a heavily used programming language, so depending on what software you have on your computer, you might have several programs written in Python. The average time needed for a test is here reported in milliseconds. Exactly. Then we have two 3D graphics workloads. As Michael already pointed out, those have been supplied by UL and Unity. Thanks very much for that, because there is not much else to be used in the open source space, and those two are actually our exceptions from the open source rule. They are still closed source and property of their respective creators. So we have Wildlife Extreme, which you might know from the 3D Mark benchmarks. And it renders various scenes in 4K resolution, scaling it then down to the size of the actual screen. The result is reported in frames per second, and similar for Unity Spaceship. it's also rendering various scenes only at full HD resolution in this case, and we also get the result in frames per second. Lastly, you might ask, why did you even develop this tool? Aren't there enough benchmarks on the market? And of course, we also asked that question, and we went through some of the available benchmarks which are readily available, and unfortunately, they all have their shortcomings, and none of them was fit for our purpose. So I just want to give you a quick overview of what is available on the market besides our tool, and what the issues with those are. So we have Sysmark. It benchmarks unmodified real-world applications, which is quite nice. It's exactly what we do as well, and is great. It has different scenarios for usage profiles, also great. It is focused on office and productivity workload. It doesn't have anything related to gaming, which is certainly, at least for some people, a relevant use case. Runtime is around 1 hour, so more or less the same as our tool. It does measure energy consumption, but it's proprietary, and also it only supports Windows, so it doesn't really work for our purpose. We have a screenshot of Sysmark. It's giving you an overall rating, just like our tool does, and then it gives you various categories for productivity, creativity, and responsiveness. Those are probably not the ones we will have in the end for a potential energy label. So also that is probably not exactly as we wanted. And again, it's not open source, so it can't be easily changed. There is PCMark, which I already mentioned regarding our 3D graphics worklet. Basically, it's relatively gaming focused. It also does have office and productivity workloads, but it's not really geared towards efficiency measurements mostly. So it can measure battery life in hours on laptops, but that's not really what we need. Again, it's only supported on Windows, and it also is proprietary, so we can't take any control over that. Again, here's a screenshot for PCMark. Also gives you a total score and various ratings for essentials, productivity, digital content creation. And lastly, we also looked at Geekbench. It doesn't use real-world application. It claims to be simulating common tasks, but it's not really specified what exactly is the content of the worklets. So it's a bit intransparent. It only has basically 2 options to run a single core and a multi-core benchmark, and nothing else. There is no way to measure energy consumption. And as the other 2, it's also proprietary. Although it's platform independent, so it would run on most of the relevant operating systems. I'm not sure if there's a specific Chrome OS version. But apart from that, it at least supports all the operating systems. Here's a screenshot of the Geekbench user interface. It gives you a main single core score and a multi-core score, but that's about it. So you don't get any further results. Okay, that's more or less.
Wait, just one thing, we just saw that we skipped a couple of slides, and you need to go, a couple of worklets were missing.
Okay.
So we need to jump up to 20. Slide 20. Or 21, doesn't really matter. You can,
I think we missed those 2 slides.
and a couple of worklets.
Okay.
Yeah.
Sorry for that. So we will just jump back again. Yeah, one important question was what is necessary for a worklet to be considered being part of the test suite. So our goal was that we want to reuse existing benchmark software or existing real world software, because that is obviously the most relevant for an end user. I mean, an end user is not going to run synthetic workloads, I don't know, calculating prime numbers up to one huge number. But yeah, an end user will, I don't know, render a 3D model or create a text document or something like that. So we wanted to use real world applications, and we also wanted to test as many use cases for a computer as possible, of course. The test setup should be relatively simple. So one of our main goals was to have no external connections, so that you are independent when running the test of any internet connection, or that your internet connection speed doesn't affect the test result, so to speak. And of course, as I mentioned several times, open architecture for the framework and for the worklets, so that we can actually change it, maintain it, analyze it, and yeah, just make it transparent what the test is doing. And then for the concrete criteria regarding the worklets, so it has to be supported on all relevant operating systems. That is Microsoft Windows, Apple, Mac OS X, Linux, at least some distributions, and also Chrome OS. It should be free and open source, with our two exceptions for the graphics worklets. We had 2 or 3 open source graphics workloads in the beginning, but yeah, those are quite outdated and they don't really exercise a modern graphics card anymore. So yeah, we just had to resort to proprietary software here. Of course, the software making up the worklet should be actively maintained. So, for example, that it will support new CPU architectures in the future. We have seen that with Apple recently. I think most of you are aware of that Apple has switched from Intel processors to their own ARM-based Apple Silicon, as they call it. So having actively maintained software ensures that such new architectures are then actually supported without GTD or whichever company having to implement all the support for that. It needs to be a workload relevant for the simulation of a typical user, as I said before. Automation needs to be possible, because otherwise, you can't do the test when you have to manually type in numbers somewhere or whatever. So automation is a critical point. It shouldn't add anything to the already existing test setup, so no special hardware or anything else like an internet connection or whatever. There is, of course, Handbrake as an exception regarding special hardware, because it uses video hardware accelerators. But there is also one configuration for Handbrake which doesn't use any hardware accelerators, so you can also run it on computers without any graphics card, which is supported by Handbrake. And of course, last but not least, the performance and power results for the worklets should be consistent and repeatable. So that means when you run the worklet multiple times, the results should actually make sense, and should be able to repeat the test also on the next day or in the next month and get the same results without any random things you can't explain. As was mentioned before, the Phoronix test suite already comes with quite a lot of potential worklets. And we went basically through all of them, selecting 46 at some point, and then narrowing it down more and more. But of course, those worklets were also not all of them quite fit to the purpose. So we had to do some changes, like for example, adding support for missing operating systems. So some of the worklets were only made to run on Linux, as Foron's test suite is coming from the Linux space. Although the software would be available for Windows, it was never run on Windows, so we had to add support for that. Some of the worklets weren't able to run offline. So for example, our browser benchmark, which we have included, was modified to run locally. Of course, we try to include as many dependencies of the worklets as possible to support offline installation. It is only working perfectly on Windows, unfortunately. So for Apple and Linux, you will need an internet connection for installing the worklets. But when you run the test, you don't need an internet connection. So the test results are independent of that. And of course, we try to automate the installation and uninstallation of the worklets as much as possible. So with our worklets, there is basically zero user interaction for the installation and uninstallation, which would be not the case with the default version of most of the worklets. And of course, lastly, we made sure that all the worklets actually run on all the computers we want to test. And for that, CLASP generously sponsored 20 computers to run the software on and test everything. Okay, now we have the missing worklets. Somehow those slides were skipped. I have no idea why. So there is the worklet category rendering and computer-aided design. We have Blender for the rendering part. It's a quite popular 3D modeling software. It can also do video editing, but we use it for 3D modeling and rendering. It can render only on the CPU or with a hardware accelerator, so similar to Handbrake. But in this case, we are actually always rendering on the CPU because support for those hardware accelerators is in the making and not quite good enough to our understanding for our purpose. The result is in seconds needed for the rendering. And for computer-aided design, we have FreeCAD. For that, we developed the worklet script ourselves. And it basically creates a 3D model and does various Boolean operations on the model and measures the time needed for that. Again, in seconds for running the script and creating the CLD model. Okay, we have two more worklets for compression. So there is one using the 7-zip algorithm and one using the Z-standard algorithm. For the 7-zip, we only do compression. For Z-standard, we do compression and decompression. So that's actually two worklets for Z-standard, using the same software in the background, but with different configurations. For 7-zip, we have a result in million instructions per second. And for Z-standard, we have megabytes per second of compression or decompression throughput as a result. The nice thing is that Z-standard is multi-threaded, so it actually makes use of multi-core processors. We do have several Office worklets. They are all based on LibreOffice. One of them is doing PDF conversions, so it's converting various text documents, spreadsheets, and presentations to PDF format. It's around 20 documents, as mentioned on the slide, and it measures the time needed for that. We have 3 more LibreOffice worklets for spreadsheet, presentation, and writer components of LibreOffice. Those are more user interactive. So the PDF thing is a batch conversion, and the other ones are user interactive. You already saw the spreadsheet Worklet in the live demonstration. So it actually pops up. LibreOffice creates a spreadsheet, creates a presentation, and creates a text document with inputting numbers, formulas, text, and so on. This is using an unmodified version of LibreOffice, so it's the same as you would get when you install it from the LibreOffice website. And again, measures the result in seconds. Then we have a browser benchmark based on Selenium. That is a browser automation framework, which is usually used for automating tests for websites. So when you create a website, you might stumble across Selenium to do automated tests for your website. We use it to automate Google Chrome and run the test within Google Chrome and also extract the result from Google Chrome. We are running the JavaScript Kraken benchmark here. There are also other benchmarks supported by this worklet, but we settled for the Kraken benchmark. And it reports the result in milliseconds for an average task executed. Okay, I think that is then everything. So Stockfish was already discussed. So I will just then jump to the last slide and give you the two links again to our website and to CLASP's website, where you can find all the software and the documentation, like the test procedure. You can also find the slides, and you can also find recordings from webinars we did 1.5 years back. That is still relevant, what we talked about there, especially the second one, if you want to know a bit more about the inner workings of the software, that is still relevant. So yeah, I'm giving back to Michael. I think you want to say a few more words.
Thank you, Thomas. Yeah, and I must apologize to our participants that I got things exactly backwards with the question and answers and the chats. So apparently our chat was disabled, and folks have realized that and used the Q&A, which is brilliant. Thank you for doing that. And I've got 9 questions here. So Thomas, if you don't mind staying on camera, I think you're going to be answering quite a few of these, but we have some good questions here. So I'll be pasting them into the chat now so everyone can see them. Can I just check, are folks able to see the chat? It's disabled, but can you at least read what's pasted in there? I'm not sure if someone could write a response back in the question and answer to say yes or no. But anyway, I'll read this while that happens. Oh, thank you. And the answer is yes, you can. Thank you. Okay, great. So I'll carry on like this. I'm going to paste them out of the question and answer into the chat, and I'll number them as we go, and then we can work together to answer them. So the first question here was that we mentioned that performance is not part of the test, but we mentioned some kind of performance data as part of the test. Now, I think perhaps that question was posted early on, and it's pretty clear now that performance is part of the test. Do you want to say something, Thomas? Go ahead.
Yes, yeah, it's quite clear, I guess. I hope so, at least. Yes, performance is part of the test. We are measuring performance for all of the worklets. As I said, for all of them, usually it's in seconds or in megabytes per second or in frames per second or whatever regarding the worklet. And yeah, we're measuring performance and power consumption, and from that we are calculating the efficiency.
Awesome. Okay, thank you.
To one thing, just to make it unclear, I hope you can hear me. It's that we measure, as Thomas said, the performance and the power demand, and as a result, what we give in the end of the day is the performance on one side and the energy efficiency on the other side. So you get both of the metrics in the end. So 2 things measured and 2 things reported.
Yes.
Yep. Thank you. Thanks, Andoni. Okay. Question number 2. How is the test setup and methodology taking into account the risk of circumvention? For example, if the unit under test has installed a software in the operating system that can detect the test itself. What are your thoughts on that?
Okay, yeah, good question. There is currently no, yeah, how would you call it, anti-cheat software or anything within our software. So you can cheat. It's not that hard actually, but of course, yeah, even if you don't cheat, you can just report false numbers in the end. So I think that's always a possibility and can't really be prevented. I guess it's then part of the job which independent market surveillance agencies will be doing to actually make sure that the test results, yeah, are correct.
I think one thought from my side, Thomas, is that the computers are actually using software such as LibreOffice and other programs that are commercial and available in the market. So it's harder to necessarily, design something to circumvent those. And I suppose something that could be done, it was something that was discussed, at least for televisions, to get around circumvention, would be to have a version of the tool that used slightly different worklets and would give a different energy result, but keep that version of the tool just for market surveillance authorities. And then they would be able to run the public version of the tool to get the rating and performance. And then they would also be able to run a version for market surveillance only, where they would see the results and then see how it compared to the public version. And if there was any gaming going on, that delta might be, of a larger magnitude than expected. So I think that we could probably put some creative thinking into this, because we're dealing with very smart equipment, right?
Yeah, sure.
And we don't want to just throw our hands up and say, well, you can actually run around and circumvent here. I think,
yeah, I think it's a good point, and at some point, yeah, we maybe have to think about that. That's right.
I got question number 3 here. Let me just type it in. Okay. Question number 3 from Steve Eastman. Steve's asking, why do we keep mentioning 22 worklets when it's actually 18, and were there additional worklets added to this version? So we were struggling with that question before the call, Steve. Go ahead, Thomas, you can answer.
Yeah, it's yeah, as of now, it's quite hard to actually count what a worklet is and what not. So I think we have 16 types of pieces of software which are actually backing the worklets, or the what we call worklets, and then we run those software pieces in different configurations. And this is the discrepancy between the 18 or 16 or whatever and the 22. So for example, for Handbrake, we have 5 different configurations for AMD accelerators, NVIDIA accelerators, Apple accelerators, and Intel accelerators, and without an accelerator. So this is just where the discrepancy is coming from. But there were no worklets added from the version discussed with Digital Europe in the last months.
Hope that puts your mind at ease, Steve. Okay, next question here relates to the syncing. How does the time sync work if the EUT is not connected to a network? Is it UUT?
Yeah, it's connected to a network for the purpose of the time synchronization. So of course, for that you need the network, but you can disable the network connection after that. Yeah, it's outlined in our test procedure how the test setup should be done regarding this. Of course, our demo today wasn't quite 100% representative, just for convenience reasons. But yes, there is a network connection for the time sync, but you don't need the network connection for the test.
Yeah. One thing that I wanted to add there is that just to make it clear that we need we make an a priori synchronization before the test. So then afterwards, we don't need any heartbeat type of synchronization between the controller and the equipment and the test. So we synchronize the clocks first, and then you start measuring. And on both sides, you have a timestamp that you can match then afterwards, knowing that the proper synchronization has been done just before starting the test. This ensures that throughout the 1, 2, or 3 hours of the test, you still keep a proper synchronization and those timestamps match. But we don't need throughout the running of the test kind of, as I said, a heartbeat or something like that to keep the synchronization in between. This is why we can, let's say, afford not having any network connection throughout the test itself.
Great. Okay, that answers that question. Question number 5. We're using Zimmer LMG 500 and LMG 95 for power measurement, both with an RS-232 port. Can those be supported? Thomas, what do you think?
Yeah, in general, I would say yes, they can be supported, but unfortunately, at the moment, they aren't supported. So there would be some effort, at least, to make them work. Yeah, we did that, as mentioned during the presentation, for several Yokogawa models and for some Hyoki models, which Apple generously sent over for us to make the support possible and test it. But yeah, we've never had the chance to work with one of the Zimmer power meters. So unfortunately, at the moment, they are not supported, but I don't see a reason why they wouldn't be supported at some point.
Is it possible if this organization were to loan it to you, would you be able to
Yes, sure.
incorporate the code necessary to the software? Yeah.
Yes, if we would have access to those devices, we could probably create the support relatively easily.
Can you refresh my memory? Was the Yokogawa WT210 also an RS-232 port power meter?
I think there are different versions. I think we had the one with the GPIB port and not the one with the RS-232. But if I'm not mistaken completely, the software we use for the power measurements, Sqlite, it does support RS-232 in general. So we would just need to implement support for that specific power meter.
Okay, so
it wouldn't be too hard, I guess.
So yeah, so Johan Ellenberger, if you get in touch with the team and we can, and you're willing to loan your equipment, we'd be happy to get it synced and incorporated into the code. Thank you. Okay, question number 6. Which applications are used for the test and on which criteria parameters are they selected for the test? Representativeness of usage or accessibility among most computer operating systems, or something else? I think you may have answered that, right, with your...
Yeah, I think we had one slide answering that. Yeah, in general, yes, of course, it needs to be representative. It needs to work on all the operating systems. It needs to actually be useful in simulating a user. That are the main requirements.
Great. If the user who is an anonymous attendee has a follow-on question, please post it in the Q&A. We do have another half an hour in the time. Just going now to question number 7. Can you say something about the measurement uncertainty of the tool?
Interesting question. Yeah. As I showed when we looked at the result viewer, you get the statistical numbers for the performance results. So you get with every result the standard error, and usually the tool is set up to rerun the worklets so that the standard error becomes lower than a certain threshold, which is configurable. I don't recall exactly what the number is. But the tool basically ensures that the measurement results have maximum uncertainty, otherwise it will repeat the worklet. What we've done for most of the worklets is that we limited the amount of repetitions from just the results we have gathered together with Digital Europe in the last couple of months. Because we know for those pieces of software how they behave, and we can say, okay, this worklet usually runs only, or put it the other way around, when we see this worklet runs 3 times in the default configuration and it's always super stable, we decided for some of them to only run it once just to save time. And for others, we decided, okay, it's not going to work when we only run it once, so we need at least 3 runs or 5 runs or up to 10 runs for some of them, just to make sure that the uncertainty isn't too large to damage the test result.
Yeah, and I think when this tool is presented in the consultation forum, we'll actually show some data on that. So the consultation forum can make that assessment if they're satisfied with the number of runs and the accepted variance between the runs for the tools. This is
exactly.
It's definitely something that the team is working on, and Digital Europe members are commenting on. So thank you. That's a great question. Our next question here is more of a comment from Bram Soren in Belgium. Cheating in a test may require a lot of manipulations and is not necessarily circumvention, which is automated testing. So yeah, I guess it's a good comment.
Yes, cheating is certainly a point which needs to be addressed in some way, I would say. I think there have been other cases where manufacturers have actually been cheating for other product categories. So yeah, it needs to be addressed in some way. Of course, the software is quite complex, so you can't just flip a switch and have better numbers. You actually have to know a bit what you're doing. But if you have a software engineer, it's currently possible, so it has to be addressed in some way.
Right. And staying on the theme of circumvention, question number 9, Anson Wu is asking, on circumvention, could the test results generate a unique hash code, I'm guessing QR code, to prevent editing of the published results?
Yeah, this could make it a bit harder, but of course you can always recalculate the hash code after tampering with your results. So it's not something which makes cheating impossible. It makes it a bit harder because you have to reverse engineer the hash function and update the hash. But yeah, it's one way to make it harder, but it's not a guarantee for anything.
Okay, thank you for the suggestion. Just fixing a couple spelling mistakes. Okay, so question number 10 from Olaf Matzner. Wouldn't the versions of the software packages have to be frozen for quite a few years to keep efficiency measures comparable and compliant with the eco-design requirements? So this is on the topic of maintenance. Yeah, great question.
That's a good question. Yeah, of course you are right. If we want to have reliable results, it would need to be frozen, but that's of course impossible because technology changes and computers change and processor architectures change and so on. And of course also software changes. So you might not be able to run an old version of the software on a new operating system or on a new processor architecture. So there will be updates to the tool necessary in some kind of interval, be it half a year or 1 year or whatever that might be. Of course, it needs to be assessed how the performance and power measurements change with those updated software pieces in the worklets. That's what we are going to use our 20 computers for. Those are kind of reference computers where we will then rerun the test and see how the numbers change, so that there can then be a possible correction factor applied to the results of the new version to make it comparable to a previous version.
Sorry, like go ahead, Paolo. Yeah.
May I add something on this because I got a similar question last week, I think. Basically, not really helpful for comparability between different models, but useful for compliance control purposes. We could keep availability of the different versions of a tool, and as a requirement for registration, for example, in April of a product, we could require a reference to the version of the software that was used for testing, so that the authority can repeat the test using exactly the same software version.
Great. So, and I guess there's also,
Yes.
yeah, thanks for that, Paulo. Question 11 is along the same lines on the maintenance side. So John Sundragon Waits has asked, who will verify that the software keeps working as new versions of the operating systems are released? And that's a
Yes,
That's a big question of maintenance.
very important question here.
mm-hmm. The maintenance.
Yeah.
So
Yeah, exactly. I will just say very briefly, we have right now, it's not really our duty, so we have really no answer to this right now. This is the big maintenance question we have here. There is no technical problem in doing it, but someone needs to do it. That's the thing. What our purpose or our work, let's say, tries to guarantee at least is that the tool that is being presented right now here provides all the means so that anyone could really do this maintenance. So this is not something dependent in the end of the day on the existence of GTD, but it's what we have as an open source tool that can be maintained by whoever is put in charge of this. Yeah, that's, I think, the good feature that we can offer right now, even though we have no answer exactly regarding who is going to do this. But anyone could. That's a good thing.
One idea that the team has discussed is the possibility of it being maintained by the standardization community in Brussels, Senelec, that the tool would be sort of passed over to a working group responsible for the maintenance. And then, as Thomas was describing in response to question 10, there would be sort of reference computers that were the original ones with the first version. And then as new versions come out, they would be tested on the earlier versions and indexed or calibrated so that the relative scale was consistent over the regulatory time period. So as software is updated, they would be tested back on the reference machines for comparability and indexing to the original scale that was adopted by the regulatory committee in eco design and energy labeling measures. That's sort of the idea, but we welcome suggestions actually from the attendees. If you have other thoughts on where this could best be maintained and what independent body would be most appropriate to maintain them, we very much welcome those inputs. So it's definitely something we're discussing now as we're getting to the end of the development of this tool. And I just typed into the chat that a request for any more questions. I have come to the end of the Q&A list. So just wondered if anybody had any more questions. We've got another 15 minutes. Very happy to stay online here and type some more. And Doni, did you want to add something?
Yeah, I just wanted to add one positive thing regarding the maintenance, since, I mean, we see more the challenging questions coming up, but I think that after 2.5 years, we can at least clearly state that we do have quite some good maintenance and update experiences that we have gone through this 2.5 years. And this means that we have survived quite some operating system and even major operating system updates and upgrades, be it on Apple side and also on Microsoft side. And the same also applies to Linux in this case. And on the other side, we have even survived with the tool major hardware architectural change, like the one that Thomas was explaining before, that Apple really switched all their CPUs from one architecture to a very different one. And nevertheless, we have been able to keep on our work, getting still results, updating quite some pieces of software within the tool. And I would even say that the numerical results are still relevant, even the old ones, even if we updated quite some versions of the tools. What we measured now 2 years ago is still relevant right now, and we survived all these changes, which shows that I would say that the tool is healthy enough to survive all these challenging situations that for sure will come also during the next years or the next decade.
Yeah, okay. There is experience on the team that we intend to document in that, and maybe on. Sorry, was I muted that whole time?
Yes, you.
Okay, sorry. I was validating what Andoni said, that there's experience on the team, and that track record of maintaining through hardware and software revisions will be incorporated into this maintenance manual that we want to put together. And I just want to add here, we just got another question in or comment from Bram in Belgium. With the variable measurement method, it may be difficult to assess when to rescale the ABC color scale in an energy label. And yeah, I apologize, Bram, I'm not describing this maintenance process very clearly or very well, if this is your interpretation. The idea is, I think about it a little bit like clothes washers. Like there's this reference machine that is used, and that's used to determine the performance of the machine under test. And what we are thinking about having are reference machines that are used to conduct the original test, and the scale is set. And then as the software is updated, the updated software will be used on the old machines to see how it changes their performance. And then that performance of the new computers being tested with the new software would be indexed according to some constant based on how the new software performed on the old computers. We know we need to do a better job communicating this. It's not sufficient to just mention it here in the Q&A, but we appreciate that it's come up from a few participants today that this issue of indexing and maintenance is critical. The team to date has focused more on what you saw today, which is working with Digital Europe to get the best possible assessment in on mode for efficiency and performance. So as we come to the end of this phase, the next phase is to work with Paulo and potentially the Sensenelec working group to establish a process for maintenance, and in that process of maintenance will be something to address this issue of indexing. So I hope that answers your question, Bram. We have a question here from Milena. Okay, hang on a second, Milena. I'm going to paste this into the chat. It's question number 13. It's directed to you, Paulo. Milena asks, Paulo, your suggestion works if the ESO or subject appointed by commission can guarantee that the performance results of the different versions of the software are either always the same, or there is a proven proportionality of the results of their different versions results. Paula, would you like to respond to that? Milena, I think, was addressing your comment.
Yeah, but I imagine that Milena wrote this right before you mentioned this solution with the indexing, and this indexing issue records me of what has been done, for example, for the equipment for rolling resistance of tires, where there is an exercise that is periodically repeated to realign all laboratories in the world to a reference laboratory that is in reality a virtual laboratory made of 10 laboratories around Europe. So indeed, we will work with Sensenelec or Etsy maybe to address this point. Indeed.
Great. And you know, this just shows you the challenging questions. This next one I'm about to post that we get from our partner Digital Europe in this process. So Shahid is writing and asking here that operating systems or worklet version changes will also change the score for A to G labeling, and these changes will not always be linear for all operating systems. So yeah, but I guess the point being that in the baseline, the reference machines, we would have all operating systems, and then the relative performance on the updated version would be indexed according to the operating system of those. So I suppose a problem would arise if a new operating system were introduced to the market that we didn't have in the reference. We definitely need to work on this, Shahid, and appreciate that comment. I don't know, GTD or Paula, if you want to add anything to that.
I just want to add at least one point is that the operating system, from the perspective of our tool, is part of the system being sold. You are buying a certain computer with a certain operating system. So of course, this will evolve with time, and whatever manufacturer is selling its computer with a certain version of an operating system, the test will be done on that operating system. So the tool itself is quite agnostic to that. You will get a certain class A, B, C, D, F, G, whatever you get with that system, on that operating system, on that day when you are selling. On the other side, we have the aspect of having the worklets being updated. And here, one thing that I want to at least point is that there are two different types of updates of the worklets. On one side, we need to ensure that whenever a certain hardware changes, we may need to update a certain piece of software to ensure that the worklet is still able to run on all the operating systems. This is one of the reasons why which would prompt an update. It is not the goal of the tool to chase every appearing new version of the pieces of software we are using. This means that whenever a certain piece of software has its new version, the software is not going to be updated because of that. It's just that if under certain circumstances, a certain operating system, a certain worklet breaks and doesn't work anymore, we would need a new version to ensure that it works again. And it's then when we're going to take the reference computers to ensure that no major change will happen in the end in the measurements that we're getting. And up to now, throughout these 2.5 years, even though we went through many versions of software, we are not seeing that many numerical changes really in performance or energy consumption in many of the worklets. There are some of the worklets that came during the last time now in, and for those I cannot state anything, but I think we are talking sometimes more about a theoretical problem that is true and it is there and needs to be assessed, but from the experience we are getting right now, it's not always the case. For the first versions of the tool that we developed, we had been using that tool developed now 1 or 2 years ago on computers that were already more than 10 years old, and there was no problem at all, and all the worklets were running. So this maintenance needs to be really addressed, and we need to think about it, but we have some quite good feelings based on the experience that we already got throughout these 2.5 years in developing the tool itself.
Well said. Thanks, Andoni. Paulo, do you want to say any closing remarks?
Yeah,
just a few minutes left.
Just to complement what Andoni was just mentioning, I was referring already to the product registration in April, and as you perfectly know, any change in any parameter part of a product information sheet or label, in principle, should lead to a registration of a new product. So this, in principle, can involve some issues if the products are placed on the market with newer and newer updates of their operating system. Anyhow, to mitigate this, one option, I'm just thinking loudly, but one option could be that in the registration process for every worklet, if we decided to register all of them, then not only the version of a software, testing software is indicated, but also the version of the operating system and any other possibly relevant software is also mentioned in order to be able for the authority to repeat the test precisely in the same environment.
Excellent, thank you, Paulo. That's a great idea. And I just got one quick question now from Bram. I forget what number I'm on. Question 15. So just paste this into the chat. So Bram asks, could a form of circumvention be that a computer is placed on the market with an operating system version number X to achieve a good score and then subsequently upgrades to operating system number X+1 or X.2, which would have a worse score? So I think that's covered in the blue, is it called the Blue Book? The Commission has guidance for software upgrades of equipment. So this came up in televisions as well, that it's shipped with one version and then you upgrade and it changes to a different mode that uses more energy. And I don't think that practice is allowed. Paulo, do you recall what I'm talking about?
Well, as I mentioned, first of all, for transparency, the registration has to should indicate the software version. But as said, if the product is then distributed with a different software version, in principle, the manufacturer, the supplier should register this as a new product if the new results are if a new operating system is detrimental for the measurements, for the scores, I mean.
Okay, yeah.
So to some extent, this risk is mitigated and not completely excluded, because indeed what Bram is mentioning could be a temptation. But I mean, the authority could check this and react.
I would also say that from the technical perspective, it's not really that, I'm not saying that it's impossible, but it's not that easy to prepare a version of an operating system which would make many or all of the worklets better in energy efficiency. This version of the operating system would become accessible to the public anyways, for a certain time at least, so that it can be tested with that. Just as imagine a certain update of Windows that Microsoft would need to make public somehow. It's really not that easy to do. I'm not saying it's impossible, but it wouldn't be the easiest way for circumvention here.
Yeah, I agree. Also, in practical terms, for example, if we are speaking of laptops, so installing an operating system that is by far less efficient would involve also having a battery lifetime that is far shorter. So from a commercial perspective, I don't think this is a temptation that manufacturers will have in practical terms. I don't think so.
Okay. On that note, I just pasted into the chat a couple of responses from Hans Paul that software upgrades are covered in eco-design, but it might be a bit more complex for computers. Note that current eco-design legislation covers upgrades on products already in use. So it is the blue guide was the name I was struggling to remember. I think that is covered there. So thank you, everyone, for attending today. We really appreciate your time and input. Lexi and I were just chatting that this is one of the best webinars that she's attended in terms of the exchange and the input from participants. So we thank you very much for that. We will be, as I say, circulating the slides and the recording of this webinar to all of the registrants, so all of you as well as the folks who weren't able to join but did register. And please do get in touch if you have further comments, ideas, or suggestions. Our email addresses are available and you'll get them in the note as well. And we'd love to hear your input and thoughts on how to make this tool better and how to move forward on the schedule that Paulo has outlined for us at the start of the session. So thank you. Good afternoon, good evening, good morning, and we'll see you soon. Okay. Bye for now.
Bye.